adventure time. Come on, grab your friends. We'll go to very distant lands. We'll shake the dog and then make it win. The fun will never end. It's adventure.
Hey Sean, what's projectile motion?
I don't know. What is it?
Look, it's conveniently on that board right there. How about you read it for us, Sean?
Oh, wow. What is projectile motion? A form of motion in which an object or particle is thrown obliquely near the Earth's surface. It moves along a curved path under the action of gravity only. You can see that in this diagram right here. It must be propelled by some force. Either it's thrown or it's propelled by a spring. And it goes up and up and up until it reaches its max height, which is change in y. And then it goes down and lands at its final spot, which is the change in x. It'll give you a second to look at that diagram. Well, a good example, I think, would be this. Hey Sam, toss me a Gatorade. Electrolytes. This is an example as to how changing the trajectory affects the change in y of the projectile. When I make the trajectory like that, the change in y isn't very much. But when I increase it, the change in y is greater. And when I increase it even more, the change in y increases as well.
We just talked about how the trajectory affects the change in y. Now we're going to talk about how the velocity affects the change in x. If I throw with less velocity, the ball does not go as far, so the change in x is not as much. When I throw the ball with a little more velocity, the ball goes farther. When I throw with even more velocity, the ball goes as far as it can go. That's how it affects the change in x.
Zan is throwing the ball to demonstrate the mathematical problem. Yeah. Oh. Yeah, and that's...
Oh, hello there. Alex throws the ball in the x direction with an initial velocity of 10 meters per second. Time elapsed during the motion is 5 seconds. What was the change in y? What was the change in x? This is our diagram. The time equals 5 seconds. The velocity is 10 meters per second. And we do not know the change in x and change in y. These are the equations for projectile motion. These are for the x direction. These are for the x direction. These are for the y direction. That's the x direction.
I knew.
That's the y direction.
These are our equations to the mathematical example. We first tried finding change in y, and that would be so we found an equation to use. and then we plugged in the numbers, and we got change in y equals 125 meters. Get a good look at that. And next we did change in x, and we plugged in an equation to find change in x, and we plugged in our numbers, and we wound up with change in x equals 50 meters. You can see that right there. Yeah.
I said a hip hop, the hip hop, you don't stop. Rock it out, baby, rubber to the boogity bang bang, the boogie to the boogity beat. Now what you hear is